Assalamualaikum and very good day to our lecturer, Dr. Nazrin. Me, Nur Syafiqah Siga, and my group member Siti Khairunisa will present about quality control of separation method. Theory of quality control. The Juran quality trilogy, the term control of quality, the concept was beginning to expand from the then prevailing after the fact inspection or detection to what we now call prevention. So who is Juran? Juran full name is Joseph M. Juran, who also known as Quality Guru. Definitions. First is quality control, a system of maintaining standard in manufactured product by testing a sample of the output against the specification. Secondly is separation method. A separation process is a method that converts a mixture or solution of chemical substance into two or more distinct product mixture. In other words, it's a scientific process of distinguish to two or more substance to obtain purity. Next is filtration. Filtration is a physical separation process that separates solid matter and fluid from mixture using a filter medium that has a complex structure through which only the fluid can pass. Then, mechanism of separation. The separation mechanism depends upon differences in polarity between the different feed components. The more polar of molecule, the more strongly it will be absorbed by a polar stationary phase. Similarly, the more non-polar of molecule, the more strongly it will be absorbed by non-polar stationary phase. Mechanism of filtration. There are four mechanisms. First is straining. It is similar to sieving. For example, particle of layer size can pass through smaller pore size of filter medium. Secondly is impingement. Solid having the momentum move along the path of streaming flow and strike the filter medium. Thus, the solid are retained on the filter medium. Next is entanglement. Particles become entwined in the mass of fiber due to smaller size of particle than the pore size. Thus, solid are retained within filter medium. Last but not least is attractive forces. Solid are retained on the filter medium because of attractive force between particles and filter medium, as in case of electrostatic filtration.
Now, we move to industrial application part, which is filtration. Quality control in filtration can be achieved by fluid sampling, centrifugal testing, turbidity testing, gravimetric analysis, and determination of particle size distribution. The first one, fluid sampling. Fluid sampling is usually taken at the beginning of the cycle, end of the cycle, and once per hour during the cycle. Traditional coring allows a sample to depressurize journey to the surface. 50 to 70% of sample fluid escape before the process even begins. The core vault system stores the sample in the natural downhole environment from the time taken to the time analyzed. Core are sealed in the pressure-tight container for bringing them to the surface. This means there is zero fluid loss, which allowing accurate measurement. Next, centrifugal testing. Centrifugal testing can be a useful technique for obtaining an estimation of percentage solid in given fluid. However, this technique is not recommended to determine the final well-bore cleanliness, as the most accurate device can only read as low as 0.05% solid or 500 ppm. Next, turbidity testing. Turbidity is the cloudiness of a liquid caused by suspended particles. These particles scatter the incident light and the liquid lose its transparency. So take apple juice as an example. It's transparent, while an unfiltered apple juice that still contains fruit pulp appears turbid. In 1864, Angelo Secchi, an Italian astronomer, invented the first turbidity measurement. A disc was used to measure the water transparency and bodies of water. The disc is lowered into the water in a horizontal position until the disc is no longer visible. The visibility depth is then determined by the Robb scale. In 1926, the standard measurement of turbidity named formazine was developed. Formazine still accepted today across the water and process industry as the leading standard. Low turbidity indicate high water clarity, while high turbidity indicate low water clarity. Next, gravimetric analysis. This test is used to determine the total amount of suspended solid in fluid. It is common knowledge that high solid content can cause plugging. This test also requires minimal equipment and provide data that is highly accurate. However, it requires skilled operator and time consuming. Last one that can be done to do quality control is by determine particle size distribution. However, this test is not recommended as it is expensive, time consuming and require trained technician.